Hi everyone, I'm Janne Porkka from VTT, Technical Research Center of Finland, and I'm going to introduce you results from SBEfin project. These results are concerning one of the pilots in the project. It's about technical upgrade in a factory to reduce energy consumption and increase employee well-being. The presentation has following sections. First, I go through the introduction and tell about the potential to save energy. Then I introduce the actual factory building project from Finland. Tell especially how the owner Abloy has sustainability strategy. Third, I tell more about the actual project, the technical upgrade, and how it's going to reduce the energy consumption. We already got the results which are over double to the target. Then I go to the monitoring of the thermal conditions in the factory. We are utilizing a tool called Human Thermal Model. And finally, I give some conclusions about the work. And since this is a video, I also give a demonstration with the actual tools from the Finland pilot. We are living extraordinary times now. In 2019, the COVID pandemic struck to the world, and after 3 years, when surviving from that, Russia invaded to Ukraine. So these global challenges are causing shortage of materials and energy crisis. It's a well-known fact that buildings are consuming over a third of the world's energy. So there is considerable potential for saving. This paper shows one example from Finland. It's also occupant behavior that has significant impact. There is up to 10% saving potential with moderate changes, and with aggressive improvements even 20%. The factory building from Abloy is located to Joensuu region, that is in subarctic or continental climate. There is 680 employees in the building, working merely in 2 production lines. One is for the lock factory and another for the closer factory. Building is constructed in 1968 and has gone through many renovations. The size is huge, almost 30,000 square meters, with spaces including office, factory, meeting rooms and restaurant. There is great saving potential with energy. The starting point in annual district heating consumption is almost 8,000 megawatt hours in 3-year average. Sustainability is important for the factory owner Abloy. They are using ISO 50001 energy management system and during the recent 10 years aiming also for carbon neutral energy. On the diagram at the right bottom, the impacts of this change mean that greenhouse gas emissions have decreased 99% since 2012. The company has also improved processes. For example, in production lines, new LED lighting saves electricity. There is also water saving. Few years ago, over 500 solar panels were added to the roof, producing almost 150 megawatt hours in a year. And this way, the energy consumption per product ton has been reducing over 10%. The energy renovation that took place in the factory meant that the building automation system was modernized. There was no structural changes. The new Caverion drive building automation system combines district heating and heat from the production line. Heating is now controlled in one system that has smart energy saving functions utilizing sensors. The picture on the left shows that there is over 30 air handling units with smart control. The target for the project was the reduction of energy consumption for heating by 1000 megawatt hours, and since the factory building is in use with minimum disruption to the production lines. The project succeeded well. The results indicate that after first year, the energy consumption for heating was 5571 megawatt hours. 29% less than earlier, meaning a reduction that was over a double to the target. And this is also estimated to increase. 2 production lines were not operated full year. The reduction will be almost 40%. Another result in the project was thermal conditions and well-being. The aim is to create tolerable working conditions for employees. Heating has to be balanced during the winter and summer periods. In Finland, the weather conditions have extremes during the year. In the winter time there may be even 20 minus degrees, and during the summertime over 30 plus degrees. One of the tools utilized in the SBEEU project is human thermal model, used for monitoring how different individuals are experiencing thermal comfort. The optimal temperature between different people may be even 6 degrees different. Depending, for example, on gender, our body compositions, varied heights, different weights, different level of fitness, and amount of muscles. In the calculations, predefined science-based person values are used instead the reality. These fictional person types indicate reality very well. And also, there is no need to ask permission from the employees. In user interface, the space and person type are selected from the top left, and on the top right there is time period for the simulation. Well-being is described with thermal sensation index. The number close to 0 is meaning neutral conditions. When the number goes to +3, the conditions are very hot, and with -3 very cold. In factory setup, the productivity of employees is usually better in slightly cool conditions. The work shows how committed owner Abloy is on long-term sustainability. The positive results from technical upgrade by Caverion has already shown a reduction, -29% in heating energy consumption. The target was exceeded, and with human thermal model, the owner is also capable to monitor thermal conditions from employee perspective. To conclude, we have presented here that there is great energy saving potential in large and complex factory building, and therefore can provide better impacts globally. In the end, we show demonstration from SBEEU project from Caverion and VTT. Building was modeled with ArchiCAD. The BIM model was used for the installation of the smart sensors that were connected to Caverion Drive building automation system to create smart functions. Through Caverion Smart View, the integration was done to VTT research platform to host pilot data in the SBEEU project. An API was built for digital twin for human thermal model. Results show remarkable energy savings and tool to monitor thermal well-being of the employees. Building data comes from Caverion Drive building automation system to VTT research platform. Dashboard shows graphically the data for 1 year on room temperature, relative humidity and CO2 emissions. There is also an integrated viewer to see inside the building. On top right, there is shortcuts to different tools to access human thermal model. When it opens, the last week data is available for viewing. Different data points from sensors are in a drop-down menu. Another drop-down menu is for the selection of fictional person types. In this case, I'm selecting man and woman and see their thermal comfort. As we can see, in same thermal conditions, male usually has warm, while woman is feeling a bit cooler. The work presented from the factory building in Finland is one of the 4 case studies in the SBEEU project. The project aims to have an ecosystem where 3 core services are connecting 16 different tools together to gain various benefits. Thank you for watching.